So in the previous video, we talked about the angle relationships in any polygon. We talked about the sum of the interior angles of a polygon and the sum of the exterior angles of a polygon. So I wrote down some of the most commonly worked with polygons in this unit. So triangle, quadrilateral, of course, but of course you can also do pentagon, hexagon, heptagon, octagon. So sum of the interior angles, sum of the exterior angles. Hopefully you remember that sum of the exterior angles is always 360 degrees. So what is the relationship between the number of sides and the sum of the interior angles? So the sum of interior angles is equal to 180 degree times n minus 360 degrees. The sum of the exterior angles is always 360 degrees. Calculate the sum of the interior angles of an octagon. So an octagon has 8 sides, just like that stop sign. So let's do S for sum. 180 degrees times 8 minus 360 degrees. 1080 degrees. So the sum of the interior angles of an octagon is 1080 degrees. And this is from the Polygon angle sum theorem. Alright, find the measure of each interior angle of a regular octagon. So if they're saying a regular octagon, they're saying that every side length of this octagon is the same, and the interior angle will all be congruent. So there are 8 interior angles and they all measure the same angle. So what I'm going to do is take the 1080. Okay, so the each interior angle, take the sum of all the angles and divide it by, well, how many interior angles do we have? Since this is an octagon, there should be 8 interior angles. If you don't trust yourself, try your best and draw a regular octagon. You know what? I'll give it a shot. Okay, not very pretty, but we're going to make do with that. Let's say that's a regular octagon. So each of these interior angles, there are 8 of them, and they are the exact same. They're congruent. If you take 1080 and divide by 8, I believe it's 135. Yep, so therefore each interior angle of a regular octagon is 135 degrees. Beautiful. Okay, how many sides does a polygon have if each of its interior angle measures 140 degrees? So what we're going to do is we're going to take that formula. So the sum of the interior angles is 180 degrees times n minus 360 degrees. But what's the sum of the interior angles? Well, each interior angle measures 140 degrees. The question is, how many interior angles are there? Well, the number of interior angles is the same as the number of sides. The number of interior angles is the same as the number of sides. So sum of the interior angles is equal to 140 degrees times n. So, what do I see? A beautiful linear equation, and we've been solving this all semester long. So really try to take your time and solve this equation yourself. Now, while you solve it, I am going to write down the theorem that we used. This equation is derived from the Polygon angle sum theorem. Polygon angle sum theorem. Switch sides, switch signs. Simplify by collecting your like terms. Oops, forgot the N. So what do you know? There are 9 sides to this polygon. It's a nonagon. Okay, so there's actually an easier way to do this question. Okay, this is one way of doing it. And I'm going to reach the exact same conclusion by doing it another way. So instead of talking about the interior angles, I'm going to talk about the exterior angles. If each interior angle measures 140 degrees, how much will the exterior angle measure? Hopefully you'll realize that the exterior angle is 108 degrees minus 140 degrees, because interior and exterior angles are supplementary. So each exterior angle must measure 40 degrees if each interior angle measures 140 degrees. So if I know that the exterior angle is 40 degrees, then guess what? The number of sides must be 360 divided by the 40 degrees, the size of each exterior angle. So this is from the exterior angle sum theorem. You know what? I'll show you a different way. Maybe this was too much, so I won't jump the step. So I'll show you 360 degrees is equals to 40 degrees times n. Because each exterior angle measures 40 degrees and I have n of those, and the sum of the exterior angles must be 360. So divide both sides by 40, n is 9. Okay, and that original 360 degrees times 40 degrees n, that's from the exterior angle sum theorem. Okay, so whether you want to focus on the exterior angles or focus on the interior angles, you will get the same idea. Therefore, there are 9 sides to this regular polygon. I know it's a regular polygon because each of the interior angles is 140 degrees. They're all the same. They're all congruent. So this is definitely a regular polygon. If this was not a regular polygon, then I can't do this question. Okay, let's try the next page. Determine the size of each angle. So this is a quadrilateral. I know that the sum of the interior angles is going to be 360 degrees. So y is equal to 360 degrees minus 115 minus 90 minus 90. That's the quadrilateral sum theorem. That's 180 minus 115, that is 65. Okay. For 3b, I can't, well, if you have the sum of the interior angles of a pentagon memorized, then you don't need to find that sum. But if you don't have it memorized, then you need to apply the sum of the interior angle formula. So I'm going to assume you don't have it memorized, but if you do, then go right ahead and solve for z. So the sum of the interior angles of a polygon is equal to, you know what, I'm going to build an equation. I really want you to practice solving equations, which is 180 degrees and, well, in this case, it's a pentagon, so it's 5. 1, 2, 3, 4, 5 sides, minus 360 degrees. So this is the sum of the interior angles of a polygon of the pentagon, which is equal to these 5 interior angles, which is z plus 145 degrees plus 3 times 90 degrees, because I have 3 right angles in this polygon. So this is 450 270. 415. Oops. And z is equal to 450 degrees minus 415 degrees. I just realized I made a silly mistake. It's 540, not 450. Something just felt off. 540. Because when I knew I was wrong, because when I think of some of the interior angles of a polygon, I think of a linear relationship. I think that as I increase by one side, I add by 180 degrees for the sum of the interior angles. So if I know that the quadrilateral is 360, I can just take 360 and add by 180, and I'll know the sum of the interior angles of a pentagon. So 360 plus 180 is not 450. That's why I knew I was wrong. Anyways, 360 plus 180 is 540, not 450. Okay, anyways, minor detail, small hiccup. 125 degrees. Let me just clean that up, it's not pretty. 540 degrees. So if someone asks me what the sum of the interior angles of a hexagon, I can just take 540 and add by 180. All right. How many sides does a regular polygon have if each interior angle measures to be 106 degrees? So you know what? I'm going to take the shortcut this time. Exterior angle equals 180 degrees minus 160 degrees. And that's degrees. Why is this true? Because they're supplementary angles. I think I forgot to do that for example 2, but it's okay. Supplementary angles. I'll go back to that after. So if each exterior angle measures 20 degrees, then I can tell you how many sides this polygon have. This is very similar to example 2 actually. In fact, it's pretty much the same question. Instead of 160, it was 140. So exterior angle, so 360 degrees equals 20 degrees. Each exterior angle is 20 degrees, and there are n of them. So this is the exterior angle sum theorem. So divide both sides by 20, and I will know how many sides there are. 18. There are 18 sides. So I'll quickly correct example 2, and I'll show you at the same time how similar these two questions are. So this one is, how many sides does a polygon have if each of its interior angle measures 140 degrees? So for example 4, it was 160 instead. But here, I really should have stated that I know that the exterior angle is 180 degrees minus 140 degrees because of the fact that they are supplementary angles. Okay, last question. How many sides does a regular polygon have if the measure of each exterior angle is 2 degrees? So this one is actually very straightforward. So the sum of the exterior angles is 360, and each one measures 2 degrees. So take 2 degrees, multiply it by the number of exterior angles, and that must be 360. Exterior angle sum theorem. All right, divide by 2, divide by 2. Whoa, 180. Whoops. 180. So the exterior angle sum theorem and the interior angle sum theorem are great. You can solve for missing angles, you can solve for the sum of the interior angles, sum of the exterior angles, and you can even solve for side lengths, or the number of side lengths, sorry. So it's really powerful. So have fun with the homework, and we'll take that up in a bit.